Okay, let's start. If you have any questions, you can stop me, okay? And I will try to answer that. And I will keep asking you questions. So if you keep answering, then it makes everyone's life a little easier, okay? We'll go through this material pretty quickly. Okay, so we will take a break after about an hour, like a 5-minute break, and then we'll regroup. Okay, so tell me what this section is of.
Ugly.
Ureter?
This is the ureter. From what species? This is from a horse, okay?
Fine.
How do we know that? It's because of these glands, okay, that are present here in the subepithelial area, okay, the lamina propria, right here. So these are mucus secreting glands, right? Take a look at it. This is all mucin. So this is mucus secreting. So it adds mucus to the urinary output. Okay, so if you see this mucus secreting gland, then you can safely call this ureter is from a ureter because it's lined by what epithelium? Transitional epithelium. So transitional epithelium, and you see these mucus secreting glands, it's most probably from a horse. How would you describe these glands? How do they look like?
Simple tubular?
Simple tubular, but you're seeing these cross sections, right? So it's also coiled. Okay, so simple tubular coiled glands. Okay, these are mucus secreting glands. Okay, let's move on to, so in this exam, let me tell you, there are about 50 questions. Okay, most of them are multiple choice. There are some matching questions. There are a couple true or false questions. Okay, so they're all based on images of these slides. Okay, some of them may not have an image associated with them, but most of them do. So let's look at this section. This is a section of a
Kidney?
kidney. Very good. Okay, so this part is the
Cortex.
cortex, and from here to here is the
Medulla.
medulla. Okay, this would be the
Sinus?
Urinary pelvis.
urinary pelvis, like renal pelvis is what we call it. And then this area right here, if we zoom in a little closer, this part, this portion right here would be the
Area cribosa?
yes, area cribrosa right here. Okay, so there are a lot of ducts that you can see here. We call them, what are these ducts? Papillary ducts. Awesome. These are papillary ducts that ultimately drain at the area cribrosa, and then it gets into the renal pelvis, and from there it goes on to the ureter. Okay, so if we go up from the area cribrosa, okay, we see some tubules right here, right? So let's zoom in a little bit. Let's zoom in. Okay, so what are these tubules that are lined just by simple squamous epithelium?
The thin loop, they're the thin tubules.
Yes, these are the thin limbs of the loop of Henle, okay? Yeah, we don't know whether it's ascending or descending, but those are the thin limbs. Okay, so if you go further up, like right here, you know, see there are the thin limbs again, but then right next to them you would see the thick limbs. Okay, these are the thick limbs of the loop of Henle, which then when they come down, they become the thin limbs. Okay, so we go further up into the cortical region. Okay, so let's look at these tubules. This would be the
Renal corpuscle.
renal corpuscle or the glomerulus, right? So the glomerulus has like two arterioles. Okay, one arteriole that comes in, that would be called the
Afferent?
afferent arteriole, and then there is an then they form this capillary tuft, right? These are all capillaries. And then there is another arteriole that leaves the glomerulus, which is called the
Efferent.
efferent arteriole. Okay, so there are this capsule is called the
Glomerulus?
this is called the Bowman's capsule, right? It's lined by simple squamous epithelium, right? So that would be the parietal layer. Okay, so there is another layer, okay, that lines this glomerular tuft. It covers the tuft completely, and that's called the visceral epithelium, right? What is it made of?
Podocytes.
Podocytes. Very good. So the podocytes make up the visceral epithelium. So they are going to help in the formation of the filtration barrier. Okay, so you have to know what makes up the filtration barrier. It's there in your lab notes. It should be there in your lecture notes. You have to know what makes up the filtration barrier, the different parts of the filtration barrier. Okay, so there are a group of other cells. So if you look at, oh, let's look at this one. See, look at these cells right here. What are these cells called?
JG cells?
Juxtaglomerular
densa?
cells. Pardon me?
Is it macula densa?
No, this is the macula densa right here. It's the macula densa is part of the distal convoluted tubule. Okay. But these cells that are present within the glomerulus, but they're just, it looks like that, like they are just hanging out there. These are all
Mesangial cells.
yes, mesangial cells. Okay, these are all the JG apparatus is made up of these mesangial cells plus this macula densa. Okay, so these are just mesangial cells. Okay, and then we need to identify these tubules. Okay, we need to know the difference between proximal. So this would be a, tell me, what tubule is this?
Proximal convoluted.
Proximal convoluted tubule. This would be a
Distal convoluted.
distal convoluted tubule. Okay. This could also, like this could, okay. So if there is a difference in the staining, like this guy, for instance, okay, they are in different, the cells are in different shades of red. Okay. That would be a
Collecting duct.
collecting duct. Okay, so proximal convoluted tube, this is proximal straight tubule. Okay, if it's twisted up like this, then we call it a convoluted tubule. So proximal convoluted tubule. Okay, and if it has more space, okay, more luminal space, it would be a distal convoluted tubule, like this guy there. That guy is probably a distal convoluted tubule also.
So is that the best way to tell those apart, is that the proximal has less luminal space than the distal?
True. So if you have all this gray stuff filling up the lumen, it's definitely a proximal convoluted tubule. This guy is a distal convoluted tubule. Okay, you see more clear space. And when you see different shades of red in the epithelium, that would be your collecting duct. Okay, so you need to know the difference between these three. Then we need to know how the kidney gets its blood supply. Okay, so let's look at it right here. Okay, so you have the renal artery coming in, right? And then it divides into the
Interlobar arteries.
interlobar arteries. Okay, and then these interlobar arteries, like this one right here, could be an interlobar artery, and then it goes across like this, okay, forming an arch. So that would be an
Arcuate artery.
exactly arcuate artery. Okay, so when it forms an arch, you call it an arcuate artery. So that will be right here in this region. From there you get branches called
Interlobular.
interlobular arteries. Okay, so from the interlobular arteries you have the afferent arteriole that supplies the glomerulus. Okay, so the blood flows through the afferent arteriole, it gets into the glomerulus, and then it undergoes a filtration process, and then it comes out through the efferent arteriole, right? So what happens then?
It
What
goes.
happens to the efferent arteriole?
It goes to the capillaries. It turns into capillaries that goes to the tubules and the paratubular capillaries, I believe.
Exactly. So it goes down, it supplies all these um, tubules, okay, and it forms a true capillary network there. Okay, here I won't call it a true capillary bed because it's all arterial. Okay, it brings in arterial blood and it goes out as an arterial blood supply because it's an afferent arteriole, efferent arteriole. Okay, there is no venous component there at all. Okay, so but when the efferent arteriole comes out and it supplies all these tubules, it forms a true capillary network. There is an arterial component and a venous component to it. Okay, so that you need to know. Okay, what happens to that? And then I need to show you another picture, like right here at the kidney itself. This is like gross kidney. Okay, so like see right here, this is called the lobe, okay, of the kidney, and this structure here is called the renal papilla. Okay, and there on the very tip of the papilla is called the renal crest. Okay, it's up here. Okay, so here is a renal pyramid. This structure right here, this triangular area right here is called the renal pyramid. Okay, renal papilla right here, renal crest at the very top. Okay, so that is just gross anatomy for you. And let's get back to the kidney. What else do you need to know about the kidney? Sorry. We need to know about how urine is formed. Okay, you need to know the filtration, how it flows down from the proximal convoluted tubule, how it flows down the nephron, and then comes back up again to form the distal convoluted tubule and the collecting duct. From the collecting duct, it flows down into the papillary duct and out through the area cribrosa and renal pelvis. Okay, you need to know that. And then let's move on to this slide. So this is a section of what?
Bladder.
The bladder, urinary bladder. Okay, so again, if you zoom in, you will see
Transitional epithelium.
Transitional epithelium, very good. Okay, and then what kind of muscle is this?
Smooth muscle.
Smooth muscle, very good. It is. So let's see it here. It's all smooth muscle. Sorry. Okay, that's good. Okay, and all these,
Nerve fascicles.
yes, these are all nerve bundles. Okay, very good. Okay, let's move on to urinary male reproductive system. Male repro. Okay, so let's leave this alone. Let's go to the testicle right here. Maybe this one is a better one. So what are these tubules called?
Seminiferous tubules.
Seminal tubules. Okay, so let's go take a look at one of these seminiferous tubules, and you need to identify the different cell types that are present in the seminiferous tubule. Okay, so the dark cells down at the very bottom, okay, like these guys, those are the
Germinal cells.
germinal cells, spermatogonia. Okay, so all these are spermatogonia. And these guys with the clear teardrop shaped nucleus that extend all the way to the lumen, these guys are the
Sertoli.
Tentacular cells.
sustentacular cells or the Sertoli cells. Okay, we need to know the function of the Sertoli cells. What do? Okay, they provide support and nourishment for the developing spermatozoa. They secrete inhibin. Okay, and then what do they respond to? What kind of receptors do they have?
FSH.
FSH receptors. Very good. Okay, and what else? And then you need to know all the cells that are present in these different layers. You have the spermatogonia, you have the primary spermatocyte, you'll have the secondary spermatocyte, you just don't see it, okay? And then you have the round spermatids, you have the elongated spermatids, okay? You have all those cells in the different layers of the seminiferous tubule, okay? And what are these cells?
Interstitial cells.
Leydig cells?
The Leydig cells, interstitial cells of Leydig, okay? And what do they produce?
Luteinizing hormone?
No,
Androgen.
they produce testosterone, okay? They secrete testosterone in response to what? Hormone.
LH.
LH. Very good. So these guys have LH receptors, okay? But the Sertoli cells have FSH receptors, okay? You have to know that. And then you have to know how the sperms flow through the testis, okay? So you have all these coils, seminiferous tubules, okay? And from there, the sperm is going to flow into the
3D testes.
the straight tubules, okay? From there into the straight tubules or the rete testis, and from there you flow through the mediastinum actually, okay? And from there into the efferent ductules, okay, that are located here, and from there into the ductus deferens, okay? So if you look at the ductus deferens, let's go take a closer look at this guy. These are the ductus deferens. right? Sections of the ductus deferens. So you see those elongated spermatids in here. But this epithelium is what?
Pseudostratified columnar.
Yes, awesome. And what is this process on the top?
Stereocilia.
Stereocilia, okay? They have an absorptive function, but there are other parts where you'll just have plain cilia. Okay, so if you go to this side, see, like right here, you won't have stereocilia, but you'll have just plain cilia, okay? So it varies depending upon which part of the epididymis you are at. Okay, so at the head of the epididymis, you have more stereocilia. Tail of the epididymis, you have more cilia. Okay, so you have to know that. And then what else do we have here? And then you have to know, let's go closer. This is another section of the testis, okay, with all the different cell types in the seminiferous tubules. You have to know what the chromosome number is for all these different cell types, okay? So the primary spermatocyte has how many chromosomes?
2N?
No, primary spermatocytes they have 4N chromosomes, okay? The spermatogonia undergo mitotic division, okay, but they don't kind of divide completely. So they hang on together. So they have like a 4N configuration right here, okay? And then they undergo a reduction division, few reduction divisions, okay? So the first meiotic division will give rise to the secondary spermatocyte, which has 2N chromosomes, okay? And they will undergo another meiotic division, okay? And it will give rise to the round spermatids that have 1N chromosome, okay? And then they shed, then there is no more further reduction of chromosomes, okay? So with 1N, the gametes are left with just 1N chromosomes, okay? So we have to know that. Okay, so that brings us to the end of the testis. Yes, no, there is another testicle right here that doesn't look too happy. Okay, so what is wrong with this testicle?
There's no lumens in the tubules.
So what else?
There's no germinal epithelium.
The germinal epithelium is kind of there, but it's not giving rise to the primary, secondary, tertiary, primary, secondary spermatocytes. You don't see the spermatozoa at all here, okay? So that is what is missing. You have the Sertoli cells, but there is no more gamete generation here, okay? So this is a cryptorchid testis. So that is one thing. Okay, so this right here is a section of the,
Urethra.
yes, male urethra, okay, penile part of the urethra. And this would be a section of the
Prostate.
gland. So all of this is the prostate gland surrounding the urethra, okay. That's it. So let's move on to the female reproductive system. So this is a section of the
Uterus or uterine horn?
uterine horn.
Ovary?
No. This is not the ovary. So did we call this the uterine horn? Let's go closer. I thought this was the fallopian tube, no? Maybe I'm wrong. Okay, let me look into that quickly. Check. So here, this would be a section of the
Ovary?
Ovary.
Ovary, okay. So what phase is this ovary in? What do you see a lot of?
Follicular?
Tertiary follicle.
Yes, so there are a lot of follicles in this ovary, okay. So this is in the follicular phase. In contrast to this ovary, what do you see?
Luteal phase, maybe?
Yes. So here's a corpus luteum. This is a newly ovulated follicle. So the corpus luteum is just forming. Okay, the granulosa cells are getting converted into luteinized cells. So you're still seeing a big antral space, kind of, but that will be quickly filled with these luteal cells to form a structure like this. So what is the structure called?
Corpus luteum?
Yes, corpus luteum. Okay. What does it produce? What
Progesterone?
hormone?
Luteinizing hormone?
No,
Progesterone?
progesterone. Okay. Corpus luteum produces progesterone. So this is important because during the early stages of pregnancy, you need progesterone. Okay. And for the entire duration of the pregnancy, you need progesterone. But during the early stages, when the placenta is not completely set up, the corpus luteum is the one that performs that function. Okay. So it produces progesterone. That's very important. You have to know that. Okay. So let's look at this follicle here. Okay. Let's zoom in and look at this follicle. What would you call this follicle? Or wait. Let's go step by step. Let's look at this follicle right here. Okay. Let's go closer. This guy.
Primary.
Primordial.
This is a primordial follicle. Okay. That's because the cells that are surrounding it are
Squamous.
squamous. Okay. So if you have squamous cells surrounding the follicles, then this would be a single layer of squamous cells, primordial follicle. Okay. If it becomes more cuboidal, then this would be a
Primary.
primary follicle. Okay. So let's look at this guy here. This is, okay, let's leave that guy alone. Primary follicle. This guy right here would be what?
I'd call it a secondary.
Secondary.
This is a tertiary follicle because you're seeing the development of the antral space. Okay. If you didn't see the antral space, we can call this a secondary follicle because there are several layers of granulosa cells. But because you are beginning to see the antral follicle, this would be, antral space, then this would be called a tertiary follicle. Okay. So let's move on to this ovary right here. So here, let's zoom in. See, this is a tertiary follicle also, but it's more well developed. Okay. This is another tertiary follicle, but this one is a secondary follicle. You see the difference? Okay. So secondary, tertiary, and if the size of the follicle is pretty large, okay, it's more than 300 microns, then you will see an accumulation of cells down here at the bottom called the cumulus oophorus, on which the oocyte resides. Okay, here's the oocyte right here. So the cells surrounding the oocyte, those guys are called
Zona pellucida?
this is the zona pellucida. See that? So the pellucida is lucid, it's clear. Think of it that way, okay? So this is the zona pellucida right here. So the cells around the zona pellucida are called it's like a crown.
Radiata.
Yeah, corona.
Corona radiata. Okay, so it's like a crown for the oocyte. Think of it that way, okay? So what do these granulosa cells produce? What hormone?
FSH? Or do they respond to FSH?
They respond to FSH.
Which cyclizes to make estrogen?
Estrogen. So the antral follicle is filled with estrogen, okay? So as the size gets bigger, the amount of estrogen that it produces also increases, okay? So here, so we have, what else do we need to know? Okay, so just like the male reproductive system, we need to know what the chromosome number is. Okay, so what would be the chromosome number for a primary oocyte?
4N.
4N.
4N. So that will be 4N. So secondary oocyte would be
2N.
2N. Okay. So the polar bodies, how about them?
Still 2. Well, the polar body should be 1N when they're given off.
So it could be either 2N or 1N, they say. Okay. So look at your notes, okay, and see what it says. You have to know the chromosome number for all of those guys. Okay. What else do we need to know? So here is the spent zona pellucida. See all of these spent, but this is the glassy membrane surrounding the follicle. Okay, glassy membrane right here around the follicle. Okay, so there it is around the follicle, but this is spent zona pellucida, which is around the oocyte. Okay, so that is that. Okay, so let's go to this. Okay, placentation now. So what kind of placenta is this? What species is this from?
Is it from a cow?
Yes, this is a bovine placenta. Okay, so you have to look at, or maybe you should see this in gross anatomy. Okay, if you see the placenta in gross anatomy, then you'll never forget. So this would be the placentome, right? It's made up of two components. So the fetal part, what do you call it? Fetal,
Cotyledon?
pardon me?
The cotyledon?
Yes, the fetal cotyledon, and the maternal part would be the
Uncle?
caruncle. Okay, fetal cotyledon and the maternal caruncle form together the placentome. Okay, so what kind of placenta is this? Is this deciduate, non-deciduate?
Non-deciduate?
Non-deciduate. Okay, so if you look at the fetal membranes, how many membranes are there on the fetal side?
3.
3 membranes. What are they?
Amnion, chorion, and something else.
Okay, good. So the amniotic sac is the one that is closest to the fetus. Okay, the fetus is bathed in the amniotic fluid. Remember that. Okay, the fetus is always in the amniotic sac. So the chorion and the allantoic membrane, okay, together they form the chorioallantoic membrane. So that bag is surrounding the amnion. It's separate from the amniotic sac. It contains all the waste that is produced by the fetus. Okay, so throughout the time that the fetus is inside the uterus, all the 3 membranes have to be intact for the fetus to survive. The amnion and the chorioallantoic membrane. Okay, But the chorioallantoic membrane is the one that forms the connection with the mother. Okay, so it keeps invading the maternal tissue. In bovines, it doesn't invade the mom's tissue at all. It just forms a connection between the epithelial layer of the mom, and there is a connection with the chorioallantoic membrane. So the chorioallantoic membrane just fuses with the epithelial layer of the mom. So that is why it's called epitheliochorial. Okay, so when it sheds, when the placenta comes out, it just disengages from the epithelium and then it just plops out. Mom doesn't lose any of her tissue. There is no shedding. So it's a non-deciduate placenta. It's like the forest. Think of deciduous and evergreens. Okay, think of forest. So when you say deciduous, then it means it sheds, right? So the leaves shed in the fall. So that's a deciduous tree. So same thing with the placenta. There is no shedding of the maternal tissue. So this is a non-deciduate type of placentation. Okay, and it's the epithelium of the mom fusing with the chorioallantoic membrane of the fetus. So epitheliochorial. Okay. So now the next step is the fetus like invades the placenta. Okay, it chews upon the placenta and then it comes in contact with the connective tissue of the mom. That's another type of placentation that we won't bother about. Okay, and then in carnivores, it even goes further, okay, and invades the mom's endothelium. Then you call it endotheliochoria. So what kind of placentation would that be? Deciduate or non-deciduate?
Deciduate.
Deciduate, because there is some loss of maternal tissue. So this is an example of epitheliochorial placentation found in cows, bovines. Okay. Now this placentation, on the other hand, this would be,
Primary.
this is endotheliochorial because this is from a dog. Okay, from a canine. So endotheliochorial. So you have to know like what type of placentation this is. Like study more about the details. Okay, is it villus? Is it like in different species? You know, like in equines. How is it? How is the connection between the mom and the fetus? What is the like the format of the chorioallantoic membrane? Okay, what does it look like in different species? In horses and cattle and pigs and dogs, what does the chorioallantoic membrane do? Okay, so now this section right here, this would be a section of the
The uterus.
uterus. So this is a uterine horn. Okay, so if you look, all these are what? Let's go closer a little bit. These guys,
Glands?
glands. What glands? Endometrial glands. Okay, so these are present in the endometrium. So these are endometrial glands. These are simple glands. Okay, simple tubular coiled glands, and these are endometrial glands. Now if we zoom out a little bit, okay, this is the muscular layer, right? The myometrium. And this myometrium is characterized by all these large blood vessels. You see this huge vascular layer in the uterus because it's very essential for the functioning of the uterus. Okay, so this is characteristic of the uterus also. The vascular layer present between these two layers of muscle. Okay, characteristic of the uterus. Now, if we go to this section, this is also a section of the
Uterus.
yes, this is another section, but this is a bovine uterus. Okay, so here is the caruncle. Okay, there's the caruncle, maternal caruncle. Okay, and this is a non-gravid uterus, and so here is the muscular layer again. Okay, there is the second layer, and you have the vascular layer in between all these blood vessels. Okay. So that is it for the uterus and the placentation. Now let's go on to the endocrine system. Okay, so what is this a section of?
Adrenal gland?
Adrenal, very good. This is the adrenal gland. Okay, there are two sections of the adrenal gland that you have to know. So this is one section, this is another section of the adrenal gland. Okay, so we need to know the different parts of the adrenal gland. So it has a distinct cortex, and then it has the medulla, right? So if you look at the cortex, let's go closer to take a look at the cortex. You have to know how the different zones look like. Okay, so this would be the zona from there to there.
Granulosoma.
So zona granulosa. Okay, and then from here to here would be the
Zona fasciculata.
fasciculata. And then very good. So from there to there would be the
Zona reticularis.
awesome. So glomerulosa, think of it like the glomerulus that you see in the kidneys. Okay, so it looks like that, kind of, right? So these round structures. So this looks like a glomerulus, so we call it the zona glomerulosa. This looks like bundles, bundles of cells, so we call them, okay, they look like fascicles, so we call it the zona fasciculata. And here, this looks like a reticular network, okay, like crossing of strands of cells. Okay, so zona reticularis. So you have to know what hormones each of these zones produce. Okay, who produces glucocorticoids, who produces mineralocorticoids, who produces sex steroids. You have to know that. Okay, and then this region right here, this would be the
Medulla.
yes, this is the adrenal medulla. What does the adrenal medulla produce?
Epinephrine and norepinephrine.
Exactly. Okay, these are all basically neurons. Okay, so they produce epinephrine and norepinephrine. Okay, so that is for the adrenal. We already did the pancreas, so we won't bother about that. Let's go to the thyroid right here. This is a section of the thyroid gland, right? There are two thyroid gland sections for you to look at. Okay, so this is one, and then this is another one. Okay, so there is a difference between the two. Okay, so what is this structure right here?
Parathyroid?
Parathyroid gland, very good. So what is the parathyroid gland made of? What are these cells called?
Sheath cells.
principal cells, right? Principal cells, or we call them chief cells also. So what do they secrete?
Parathyroid hormone?
Parathyroid hormone. What does it do?
Increases the blood calcium.
Yes, awesome. So the parathyroid hormone increases blood calcium. Okay. So now let's come to the thyroid gland right here. Okay. So the thyroid gland is characterized by the presence of these structures called
Follicles.
follicles. So these follicles are lined by
Isn't it like low cuboidal to occasionally columnar, depending on what's happening?
okay. So what are these cells called?
Follicular epithelial cells.
Very good. Follicular epithelial cells. Okay. So what are these cells?
Parathyroid cells?
No.
Parafollicular cells.
Yes, parafollicular cells. Parathyroid is only here. Okay, the dark gland that you see embedded in the thyroid gland, that's the parathyroid gland. But these cells, they are in the thyroid itself. Okay, these are parafollicular cells. What do these cells produce?
Calcitonin?
Calcitonin. Awesome. So what does calcitonin do?
It decreases the blood calcium.
Very good. So calcitonin tones in the calcium levels, blood calcium levels. That's how I remember it. Okay. Brings down the calcium levels in the blood, and the parathyroid hormone has exactly the opposite effect. Okay. So this thyroid gland, if you look at it, it's filled with this pink colloid. Okay. And that contains thyroglobulin, okay, which is essential for the synthesis of the thyroid hormone. Okay. So the thyroglobulin is taken up by these follicular cells when they have to make the thyroid hormone. Okay. So when they take in the thyroglobulin, they leave empty spaces like that. You see these white spaces look so pretty, like a lit up town or whatever from the space. If you're looking at it down from a plane or whatever, it'll look like a lit up village. So this would be the spaces where the thyroglobulin has been taken up by these follicular cells. So if you look at this gland and the other section, who do you think is more active?
The one with more spaces.
Yes, so this is a more active thyroid gland, and this gland is kind of on the quieter side, okay, because it's not actively taking up. I mean, it's taking up a little bit, here and there, but not as much as the other gland, okay. So that is thyroid gland. So now let's go to the pituitary right here. You have to know the different parts of the pituitary, okay. The pars distalis, pars nervosa, pars intermedia, and the pars tuberalis. You have to know the different parts of the pituitary, okay? And what cells are present here in the pars distalis?
Chromophils and chromophobes.
Chromophils and chromophobes in general, right? You have the acidophils, the basophils in the chromophils, and have to remember, make it simple, okay? Remember that acidophils secrete growth hormone and prolactin. Okay, just remember that. Don't have to remember anything else. If you remember that, then you can by a process of deduction, find out what the other guys secrete. Okay. So corticotropes secrete what?
Corticotropic hormone.
Exactly. Okay, it's right there in the name, corticotropes. So adrenocorticotropic hormone, okay, which is going to act on the adrenal cortex. Okay, what do the lactotrophs secrete?
Prolactin.
Prolactin. Again, it's in the name. What do tropes secrete?
Can you repeat that? You cut out when you asked what it was.
Somatotrophs.
Growth hormone.
Growth hormone. Somato, like soma, body, right? So for the growth of the body, you need growth hormone. So corticotropes, lactotropes, somatotropes. Then you have thyrotropes, right? So that acts on the thyroid gland. So it's going to produce thyroid stimulating hormone. Okay. Then you have gonadotropes that are going to secrete.
FSH and LH.
Yes, awesome. Okay, so you have to know what these different cells secrete. Okay. Okay, so now let's go to the pars nervosa. So what does the pars nervosa secrete?
Oxytocin and vasopressin.
Yes, never forget that. Okay, oxytocin and vasopressin are the only two hormones that come from the pars nervosa. Okay, so it doesn't have like cells that produce oxytocin and vasopressin are not localized here. Okay, those cells are in the hypothalamus. Only the nerve terminals are present here. So you will have like spaces where there is accumulation of these hormones. See, look at that. All those dark spaces are where oxytocin, you can't say whether this is oxytocin or vasopressin, but the secretion from those neurons can be found here. Okay. What are these cells called? The other cells that are present. They have a specific name.
Suicides?
Pituocytes. Okay, so they are called pituocytes and they are present only in the pars nervosa. So they are very similar to glial cells. Okay, because all this is nervous tissue. Okay, nerve terminals and all these brown uh, things that you find here, this brown substance is nothing but oxytocin or vasopressin. We don't know what. Okay, so that is that. And then you have to know where melatonin comes from. Okay, what intermediate lobe of the pituitary secretes. So those are things that you have to know. Okay, for the endocrine system. Let's move on to the sense organs now. Special senses. Okay, you have to know these three different eyeballs. Okay, be able to identify like the gross parts. What is the fibrous layer? What makes up the vascular layer? What makes up the neural sensory layer of the eye? Okay. What are the different parts of the cornea? Know the different layers of the cornea. different parts of the iris. Okay, so you have to know the anterior limiting membrane right here. Okay, what is this muscle down here?
Sphincter muscle?
It's a sphincter muscle. Okay, and the dilator muscle is right underneath here. Okay, can you see that teeny bits of pink that you see? So it will be present. See, you can see it more distinctly here. So it's going to be present throughout the length of the iris, the dilator muscle. Okay, the sphincter muscle is present only at the free end of the iris. Okay, right here. So this is the lens, right? And this would be the lens capsule. Okay, then you have to know the different parts of the retina. So this would be the photoreceptor, nuclei of the photoreceptor cells, okay, outer nuclear layer. This would be the layer of bipolar neurons, okay. So this would be the inner nuclear layer right here, okay. This is the ganglion cell layer right here. Okay, and then so this is a section of the eye where you don't have any tapetum. Okay, so you look at this, you don't see any tapetum, you just see the choroid. There is no tapetum here. Okay, this section on the other hand, let's go down there. This would be what kind of tapetum?
Fibrous?
Fibrous tapetum. Okay, this eye right here, so you have to go down here. See here, this would be cellular. Okay, so cellular tapetum, that one has fibrous tapetum most probably from a bovine, and that one has no tapetum probably from a pig. Okay, pigs and man are the only two species that don't have any tapetum in their eyes. Okay, so all the different layers of the retina, especially the outer nuclear layer, focus on the nuclear layers. Okay, and then the tapetum, the iris, the fibrous and the vascular layers of the eye, and the lens, and the cornea. Okay,
Can we go over really quickly what makes up the vascular versus fibrous layers?
okay, so the fibrous layer, let's look at this. So the fibrous layer is made up of the cornea, the limbus, the sclera. Okay, so that makes up the fibrous layer. The choroid makes up the vascular layer. Okay, choroid, ciliary body, all of that makes up the vascular layer. And the sensory layer is made up of the retina. Okay, so let's look at the eyelid right here. Okay, so this is the third eyelid, right? So if you look at the third eyelid, so there is a gland here. How would you describe this gland?
Isn't it mixed? Doesn't it have like sebaceous?
Seromucus.
True, true. So it has a serous component and it also has a sebaceous component, right? So what is the secretion called?
Seromucus.
No, it has a specific name, like a sweat gland produces sweat, right? So what does this gland produce?
Is it a lacrimal gland?
No, it produces mebum. Have you heard of it? Meibomian gland is what this is called. So it produces mebum, which is like a sebaceous secretion. It's greasy, but like sebum, it's called mebum. Okay, so look at your notes and then identify what it produces. Okay, okay, let's go to the year. Okay, here is the year. Okay, we need to know the different parts of the inner ear. Okay, the semicircular canals. What is the sensory component of the semicircular canals? Do we know? It's called crista ampullaris. That sensory portion looks like a bud of a flower. Okay. And all these sensory regions contain hair cells. Okay. And they might have some kind of a cap or a covering that stimulates these hair cells. And sometimes it's associated with stones called otoliths. Okay, so the crista ampullaris has a cap called the cupula. Okay, so that's the sensory part for the semicircular canals. So because they are in 3 different planes, what can they sense? Balance, and then like rotation, like any angular movement is what they can sense. Okay, so that is one thing. Now, so that is one space, right? Like one space of the ear. So semicircular canals. So then there is another space called the utricle and the saccule. So these are enlarged spaces associated with the inner ear, right? And they have sensory regions also. What are they called? The utricle and the saccule. The macula, okay? So that is the sensory part for the utricle and the saccule. What can that detect?
Isn't that like lateral movement, like either backwards or forwards or side to side?
Like linear acceleration is what it can detect. How fast you're moving in one direction. Okay. And then we have the cochlea. That's another space associated with the inner ear, except that it keeps going around like a snail shell. So what is the sensory component of the cochlea? That's the organ of contact. Okay, so that's the sensory part of the cochlea. So let's go take a closer. We don't have in this section that we have, we don't have an example of the macula, we don't have an example of the crista ampullaris, but we definitely have good examples of the organ of Corti. Okay, so we need to know what these different spaces are called in the cochlea. Okay, so this would be the
Scala media.
this top portion.
Scala vestibule.
Yes, scala vestibuli. Okay, and this one is the
Scala media.
scala media, and this one is the
Scala tympan.
tympani. Okay, so I will tell you like an easy way to remember the scala vestibuli. Okay, so the membrane that goes across here, you see this membrane? That's called the vestibular membrane. Okay, so when you have the vestibular membrane on one side, this becomes the scala vestibuli. This is the scala media because it's right in the middle. And this one would be the scala tympani. Okay, so this membrane here is called the
Basal.
basilar membrane. Okay, that's the basilar membrane. This would be the
Vascular.
stria vascularis. Okay, so that is going to secrete the fluid that is present here, which is
Endolymph.
endolymph. Awesome. Okay, so this is endolymph. So these are all the hair cells. Okay, so this is the sensory part of the organ of Corti. Okay, right here. This membrane, can you see this membrane here? That is called the
Tectorial membrane.
tectorial membrane. Very good. So vestibular membrane, tectorial membrane, basilar membrane, hair cells and sustentacular cells, the stria vascularis right here. Okay, so this would be the spiral ganglion. Okay, there. Okay, so vestibuli and all of that. We talked about the sensory portions of the inner ear. Okay, that's all I have for the ear. So these two spaces are going to be filled with perilymph. Okay, and this space here will be filled with endolymph. The scala media alone will be filled with endolymph. Okay, so that brings us to the end of the special senses, but we need to go through the skin, right? Integumentary system. Let's go here. Oh, it's 11:17. Do you want to take a break or we can just finish in like 20 minutes? I wasn't looking at the time. I'm sorry.
We can just get going.
Okay, so you have to know the different parts of the stratified squamous epithelium. Okay, you need to know the different, identify the different layers of stratified squamous epithelium. So stratum basale, spinosum, stratum granulosum, of which you can't see a whole bunch here, but then stratum lucidum. And then if you have something on the very top would be the stratum corneum without any nuclei. Okay. Okay, let's go look at that section. So this would be
A hair follicle.
a hair follicle, but what is different about this hair follicle compared to this?
Is that a whisker?
Yes. So this is a tactile hair. Okay, it has lots of sinuses around the follicle. Okay, let's go closer. See, these blood sinuses, blood-filled sinuses, you can see them only in tactile hairs. And compared to the normal hair follicle, see how big the size is, okay? And this gland right here, what kind of gland is this?
Sebaceous?
Sebaceous gland, very good. Okay, see, this is sebaceous gland. What mode of secretion does the sebaceous gland employ?
Holocrine?
Holocrine, very good. Okay, so now this would be a
What gland?
Gland?
sweat gland, very good. So this is a sweat gland. Okay, here is a good hair follicle. Aha, okay, let's go in closer and I will ask, this is like trying to find a nice, okay, we'll work with this for the time being. We'll go. So this would be called the
Internal root sheaths?
internal root sheath. That would be the
External root sheath?
external root sheath. Awesome. Okay. And now this is the shaft of the hair itself. Okay. So this outermost region, I don't know if you can see it really well. Let's go zoom in closer. Maybe we'll find it. Okay. So if you see this outermost, it's kind of serrated, right? So that's called the
Cuticle?
cuticle. And this one will be the
Cortex?
cortex, and this would be the
Medulla.
medulla. Awesome. Okay, so this is the shaft of the hair, and this is the follicle itself. Okay, hair follicle. So you have to know the different types of hair follicles, the anagen, catagen, and telogen, because it will be useful in the clinics. Okay, know those. And this is the sebaceous gland again. You have to know the different types of secretion that these glands use. You know, there are like associated with the skin, there are different modes of secretion. There is apocrine secretion, right? There is merocrine secretion, there is holocrine, and then there is cytocrine. Okay, so you have to know who uses what. So for example, let's move on, not to this section, but let's move to this section. Maybe I can find a good section, good example. All these guys are dark, which must mean that they are rich in what? Look at these guys. See how dark they. There are like lots of melanocytes here. Okay, melanocytes. So their mode of secretion is what?
Cytocrine?
Cytocrine. Okay, melanocytes use that. So this is slightly cornified. I'm trying to find a good example of different. What does this do when yo? What did I do? Okay, let's bring that down. What did I do? The whole thing disappeared on me. Okay, all these guys, all these cells are called what? They have one common term.
Epithelium?
These are all epithelial cells, but there is a common term for the skin.
Keratinocytes?
Keratinocytes. Awesome. Okay. So there is, maybe I'm in the wrong section. Let me find you a good example. Wait. Why is this so enlarged? How do I get out of this view? Zoom out. Does that help? It won't.
You can just do a command 0, I think.
That's what I did, but it didn't work. Okay, let me find another way. Maybe we can. Okay, let's go closer to look at this. See, I can't even. What happened? Let me close this whole. Ah, better. Okay, so let's zoom in. This is not a good piece. Maybe there. Yeah. I'm going to turn this around like this for us to see. Go 20x. Aha, beautiful examples. Okay, tell me who these guys are.
Those the macrophages?
No, these are guys that can sense pressure.
Tactile cells.
These are Merkel cells, okay? They are usually rounded, okay? They have this space around them, okay? These are Merkel cells. But if they are placed horizontally like these guys, okay? Those are all macrophages and they go by a special name. Guy here.
Interepithelial macrophages?
Okay, they are called Langerhans cells. Technically, they are intraepithelial macrophages, but these are all called Langerhans cells. Okay, Merkel cells, if they are down at the bottom, they are round and they have a halo around them. Okay, and if they are elongated, okay, and they are kind of horizontal in the epithelium, you call them Langerhans cells. Okay, and if they have lots of brown pigment in them, they would be called
Melanocytes?
melanocytes. Okay, so that is how you differentiate these three types of cells. Okay, so those are the different cell types. What else do we have to know? So sebaceous glands again. Okay, and this is just dense irregular collagenous connective tissue right here. Ah, okay, so now this would be a section of what?
Is it a mammary gland?
Yes, this is a mammary gland. Okay, and what are these concretions? This is mineralized milk. Okay, corpora amylacea is what we call them. Okay, and all these white spots are because of the fat that is present in the milk. Okay, so that is for, you have to know the hoof. Okay, so this is the stratum externum, then the stratum medium, and then the stratum internum. Okay, for the hoof wall. So all these layers are made up of tubular and intertubular horn. You have to remember that. Okay, and then this part is where the dermis, this is all dermis, right? And the dermis sends primary dermal lamina and then secondary dermal lamina that interdigitates with the epidermis. Okay, so the epidermis extends from here and then it has a primary epidermal lamina and secondary epidermal lamina. Okay, we can go closer to take a look at this. So you have to know what the dermal lamina is, primary, secondary dermal lamina. Okay, that goes here. This is primary epidermal lamina, secondary epidermal lamina, which is the blue stuff. Okay, so they interlock with each other, so it prevents them from separating out. But when you have laminitis, which is the part that gets inflamed? It's the dermis that gets inflamed. Okay, this is what is called as the sensitive lamina. So this is inflamed, that is what we call laminitis. Okay, you have to remember that. Now come to this section. So this would be what? Anal glands. Okay, so this is the anal sac right here. These are all anal sac glands. This is the circumanal gland, which looks like a piece of liver, so we call it hepatoid circumanal gland. Okay, looks like the liver almost. Okay, so we call it hepatoid circumanal gland. It's kind of a modified sebaceous gland. Okay, so hepatoid circumanal gland there, anal sac glands right here. Okay, and that's the anal sac itself. Okay, so that brings us to the end of the integumentary system. So I think that is all we have, right? Do you have any specific questions? Yes, no?
I actually have a question, Dr. Sheba.
Okay.
Can you clarify, you have your primary and your secondary lamina, and they interdigitate with what again?
With each other. So the primary, so there is the epidermal laminae, right? So this is the primary epidermal lamina, secondary epidermal lamina right here. So let's go here. So this is the primary dermal lamina, secondary dermal lamina right here. So the secondary dermal lamina interdigitates with the secondary epidermal lamina. So that's how they hold on to each other.
Thank you.
Okay, what else? Okay, if you don't have any questions, that brings us to the end of this review session. Thank you all for coming. And
Thank you so much, Sheba.
Dr. Sheba, I did have another question. I was going to wait till the end because it's not really relevant to the class, but just something kind of interesting that I was wondering about when you were showing us the thyroid.
Okay.
So I noticed that the follicles on the thyroid seem pretty large, but all of the colloid like manages to stay in when it gets like stained and fixed to the slide. And I was wondering if there's something special about the colloid, because I know other things that we've looked at, like the stuff inside of certain things get like flushed out, but the colloid stays so well fixed that you can even see the little parts where it's like picking up the little what were you saying? The spots where all the colloid is taken up by the follicular cells to make the thyroid hormone. You can even see those like little holes. I just thought that was kind of wild.
It's because this colloid is very dense. The thyroglobulin is a large protein. It's like, I want to say 234, maybe 600 something kilodaltons is how heavy it is. You know, it's a huge protein. So the design of this follicle is not to be synthesizing this large molecule all the time, okay? So it synthesizes it once and it keeps recycling it. So it stays within the colloid, okay? It gets into the cell for a little while, but then it is shipped back into the colloid. So because it's a large molecular weight protein, it's pretty well preserved in sections. It doesn't wash off easily. And it's not dilute, it's thick. Okay, so that's another reason why it sticks on to the sections like that. And it is kind of cool, you know, where you see these spaces where there is actually pinocytosis, where the cells drink up some of this colloid and they leave, because it's so dense, maybe they leave like a space there and they take this colloid up. So this thyroglobulin has lots of tyrosine on it, tyrosine moieties, and the tyrosines get iodinated. Okay, and it's the iodine that forms the T3 and the T4. The iodine and the tyrosine together, they form T3 and T4. I have like a cool schematic that describes it. Maybe I can send it to you, Alex, for you to look at. But
Cool.
the rest of the thyroglobulin gets shipped back into the colloid. So it conserves the energy that way, which is like very cool. Any other questions? If not, good luck to all of you. You are welcome to come again tomorrow if you want. Okay. We'll have another review session at 4 o'clock.
This
Thank
was so helpful.
Yeah, really. Thank you so much, Dr. Sheba.
You're welcome. Bye, guys.
Thank you so much.